Alright everyone, so welcome back again to another new tutorial on our RTS series. So I've been working a little bit on since we last made a video about it, and now I have touched on the project a little more, and here's what I've come up with. So yeah, now we can basically start the gathering procedures here for the unit, and as you can see here, there is some debug information that I have been put in. So behind the scenes here, I have actually implemented a lot of different systems here that we're going to be seeing on this tutorial. So there's a lot of things to catch up with. You're going to see that I have here an action for harvest, an action for gather. I have now object prefab, which I spoke on the last video. I'm going to show you how that is implemented and used. So far, we are still not collecting resource for the wood itself on the tree, but as you can see here, I'm already working on that. So the next step will be to simply deduct the resource information from this object. So yeah, now actually trees have a simple script. And if I show you here the script for the units itself, for the basic units, so that's going to be, you can see that, yeah, I have simplified even more the script. So the selection functions are gone. The movement functions are also gone. The request new path method is gone. So everything else here from the object have been stripped away even more so, and even these things here are stuff to do, so I can remove them later. So as you can see, now the units are getting the information from the prefab data, and the prefab data now stores the action and everything for the unit. So as you can see, this is what my prefab unit, the data for it, the unit looks like. And as you can see, here's the information I'm using for the unit. I'm not actually passing this information back to the object data, but as you can see, yeah, a lot of cool stuff happening here. And I don't know if you have noticed, but the scripts where I have preloaded a bunch of different scripts now are gone. So what is the secret for that? I've actually decided to make an autoload to store the scripts itself. So I think I should have done this a little bit before, because now we have quite a lot of different scripts, and doing it through an autoload also helps us with managing the dependency cycling, which can happen if you are preloading a bunch of different scripts intermingle between themselves. Now that we have an autoload will surely load before anything else is loaded here, even though they are preloaded. When you have two scripts preload one another and lose one another, you have a cycle of dependency. But now, because we have an autoload for scripts, everything is preloaded first, then the dependencies can happen later. So this also helps us with dealing with dependencies. And as you can see, because this is an autoload, every object that we use here, whenever we want to access any bit of those scripts, we simply call scripts the autoload name for storing the scripts. And I did this because a lot of different systems were using the preloads, and there was a bunch of things that the preloads have special name and use cases, and I think that for general things like these, so for important scripts and for important objects, we can preload them here, and we can call that for anything else. But the idea with this autoload scripts is not to store any kind of function or data or var that we're going to use for other objects. This is not the idea for this is not to make a global object to manipulate information, but rather just to list all the scripts we are using, and also some aliases from the scripts themselves. But yeah, that's basically an improvement I have made. So the scripts got cleaned a lot as well, because there were a bunch of preload information there that was just a pain in the ass on managing between different projects. So that is something we have to update on our project as well. What else I have made? So I'm actually using this software here. So this is WinMerge, and there's a version for a software similar if you're not using Windows. I believe there's one for Linux, I forgot about it, but basically this is a software that allows you to compare different folder project structures, text files, to know what is different. So if I access here, globals, you're going to see that this was the tutorial for Godot part 5, and this is my current work in progress. So the right side here is the new information, and then the left is a previous information. So let me open here one of those scripts that we have changed. So for instance, the object data main manager, you can see here the different things we have done. So you can see they have removed the script, I have changed some things. So this will allow me to make sure that the project stays consistent, but of course you're not going to see everything I see there. This is just to guide me to make the tutorial for you guys, because there was a lot of changes. So I'll see what's everything changed, and I'm going to do the best I can to also follow it. And as you can see here, we still can load some other scripts, but the script system for the stuff that we use the most, like if I go here on the action, Autoload scripts, yeah, there's a bunch of things we make use of. We have object data for the constants things, we have the database for the prefabs, there's a bunch of different stuff. So let's go ahead and update our project last state so we can be doing something like this as well. So units have also now some timers to calculate the gathering, and also for the future use of attacks. Yeah, a bunch of different cool stuff. So let's see a lot of these changes and how we're going to implement to improve our RTS project for continued development. So let's go ahead. Okay, here, so let's go through the project changes from the last part. So I have duplicated the tutorial part 5 to now become the tutorial part 6, and we're going to see a lot of the changes we're going to be doing here. So one of fix I'm going to do here very quickly is just going to the action move. So whenever you move the units, they're going to jiggle a little bit on the first frame, and that's because they are starting on the path index 0 rather than 1. So we're going to simply fix that by going on the action move and going to replace here the start index with 1. So now whenever you move units, it should start a little more clean and they will not jiggle on the first frame. As you can see, a lot more responsive here. So this is just a little bug fix. Next, we are going to change here the scripts. So everywhere where we have a script to be preloaded here, we're going to make sure they are all the same, and we're going to preload them inside the script manager we're going to call as an autoload, because this will help centralize all the scripts. Because if you see here under the new project, if you check here the new project, the scripts themselves are only referenced the scripts here. So none of these scripts now have the preloaded requirements from other scripts, so this is a lot more clean. So in order to do that, we need to replace all the scripts here with that structure. So first, let's create a new script. This is going to be our autoloads for the scripts. So this is going to be a simple script, and we are going to extend from node so we can instantiate as a autoload. Let's clean this up. Let's go to the project settings, add it as an autoload. So let's go under globals. Let's add our autoload as scripts. And now should be good to go. So now we're going to go ahead and make sure we are keeping the same name throughout the project. So wherever we have a preloaded script, we're going to first make sure they are all the same name. So now let's just replace the act scripts by now being actions. So instead of act scripts, we're going to replace them as simple actions, as you can see. Let's replace those. Now let's replace the act names to be called as action IDs. So we are doing some reformatting here. Keep everything consistent. Our object data can be the same, states and signals. So let's check here very quickly if everything should be named appropriately. So here we can see an example of where it's wrong. So we are actually using object data. So let's update here our object data main manager. And let's actually replacing files in case of there being other places. So yeah, can replace those. So yeah, it seems everything here has been renamed appropriately. So now let's go through and let's start copying all of these scripts inside of our autoloads of scripts, so we can start merging all the scripts together. So basic unit has some. Let's see here. I think these are all the things. So now what you're going to do is go to replacing files, and now you're going to replace by the scripts, autoload, and the name you want. In this case, we still want to keep the name as action manager, but change this to be now scripts action manager. Then we can just remove this line from the autoload to keep it as like that. So let's keep doing this. scripts.data manager. A lot of references for this one. Place and remove the scripts here. Save, place. This I'm going to change to be state signals rather than just signals, because it's related to states. Now we simply want to remove all of these, so let's actually replace with nothing. We can simply remove the script line. Now let's see where every script uses those. So as you can see, all of those preload variables now can be deleted, all those constants. And we're going to do that for every single one that has these scripts defined, because now it's an autoload. We do not need to preload any of those. So we can simply clean a lot of those scripts, even this one. So this is the case where the name has not been defined yet. So if we double check here, our action scripts is now actions. This is actually action IDs. So let's just fix this. This is code for the action main manager. Constant doesn't have anything. Here we can delete this one. So this scripts data list is not needed because we already have it. Because object data inside of the scripts is already the data list. So we do not need to specify it twice here on the code. So we can remove that. It constants, the main manager can delete these ones. What's going on here? So we could not resolve state, so it's just a matter of fixing the code here. Same with this one. And I think that does about it. So every state should be fixed now. Let's run the project, see if we've got any issues, and everything should be running just like before. So now our code should be putting references towards the autoload scripts rather than have a bunch of preloaded constant scripts here. This is the main manager, so these are the scripts for that. But as you can see, no longer we need the references back to on the top there. So this helps with managing our project. Okay. So now another thing we're going to do is to strip away from the object basic units all the codes that basically selects and deselects an object. So these functions are the direct translation of me calling directly the action selectable, but rather than through the object actions, doing it through the action itself. So we access the scripts, the action selectable, and we deselect the object and doing this back and forth. So let's remove those from the basic unit code. Let's go to our selection manager and let's simply update it with the new ones. So the last thing is we need to pass the arguments on these functions, and we need to call them here as well instead of self, because now we are actually calling the units. So whereas before we're accessing the units object codes to call it through that, now we are doing it a little bit differently. So that should be good to go. So now it's also called a little bit different. So as you can see now, we are, instead of calling the object.select, we're going to call directly the action of selectable to select, deselect, and toggle select. So now our basic unit can get rid of the codes that actually does the selection, and we're also going to do that for the new path here. So let's go ahead and to do this to the new path. So instead of storing the new path function inside of the units, we're going to store inside of another object we're going to build, which is going to be the Rts World. So this in the future will be the RTS that's going to process all the units requirements. So let's go here under the objects, the RTS systems, and let's create a new folder. It's going to be our Rts World. And here we're going to add the simple scripts as going to be the main one for this. So the Rts World is going to be this node here. So let's go ahead and assign it. This is main from the folder of the Rts World. So this is the Rts World.main, and we're going to extend from nodes 3D, and we'll go do some stuff in here. So instead of the selection manager the units here, pardon me. So instead of the units calling for a new path, we're going to say that this is going to be exactly where we want the RTS worlds to come in. So let's update this function to be used by this one. So we cannot pass self, so we're going to need an object caller to generate a new path and a destination. So now we can pass the object caller here, and now we can simply use these as we see fit. So now that we have the new path defined in the RTS world, next our selection manager needs to reference that, and we're going to do that as, and actually you can do this a little bit different, and this is not even on the selection manager here. So the new path is being generated from the RTS player, I believe. So if I go here, and there we go. So move units to mouse, you can see that it executes a new path. Whereas now we want to remove this function from the objects. So we are going to do that through the scripts dot, and this is where the RTS world will come in. Of course, we do not have that code yet, so let's add here. So let's add as a constant RTS world. It's going to be the preload of our RTS worlds dot main. So for static functions, we can use these as we see fit. And it's going to call the new path, and it's going to request a object caller and path. Let's do this as static, see if that's possible. So the auto-completion can auto-detect here. And it seems to be missing an argument, but it did not even throw an error here. And now it did. So it's going to need to pass the object, then the where2, which is going to be the mouse collision on map. So now let's just copy this information here for every other call for this function, which is for whenever we right click on resource objects. And now we need to pass the resource position and the object. Right, so now because we have done this, we can go ahead to our basic units and also strip away this bit of code here, which was the method to call a new path. Because now it's calling directly from the RTS player using the scripts RTS world, which in turn has preloaded, and it's going to allow us to do a new path. So if we run a project, units should be able to move without having that method defined inside of them. So yeah, pretty neat. So we have cleaned our basic units a little more. So now let's add the prefab data system structure to our project so we can start messing around with object data here to be stored. So let's go under the RTS scripts here. Let's create a new folder, which is going to be our object prefab. And then next we're going to be adding a new script, and this one is going to be our main manager. So this is going to be responsible for fetching the prefab data. In just a minute we're going to add stuff to it. And let's create a database for our object prefab, and this is going to store the main database for us. So now if we start to build our constant database, let's do it by first putting here a enum. So this is going to be our prefab list, which is going to host the prefab enums for things we are going to use. So at first we're going to have a database for units, and we want to have the units which is going to be our worker units. So this is going to be our first enum. Let's go towards constant and let's add this database. So let's add here a constant to be our database for units. So this is not going to actually use that enum, it's just going to hold us here so we can actually call it later. So this is going to be a dictionary, and we're going to add this information on it in just a second. So here we can start adding our prefabs, which is going to be our unit worker at first, and we're going to add information through it. For instance, now we can access the scripts, Autoload, and call for object data, for example, with the move speed being 12. And this we can actually apply later back to the units. Then next we want to assign here the object data, and we're going to call for the object actions ID. So now we're going to be listed inside of an array for this. And I don't know if that we have. So yeah, we do not have those. So the action IDs. So let's add here the object constant. So it's not object actions IDs, it's object action IDs. And here we can simply now type the actions we have. So at the moment we have the script action move, and we also have the action selectable. And now we can use that inside of our units to do this basically as the same. So now that we have that, let's go to our main manager and do a fetch function. So whenever we want to retrieve a prefab information value from the prefab data, we're going to call this function, which is going to return a variant, which is simply to return the key from the object prefab database. So now let's build a initializer script for the object prefab, which is going to save the information we have stored here back to the object itself. So this is going to call as is the initializer. And the job of the initializer is going to be process the object prefab back to the object itself. So let's do a static method. This is going to be the initialize prefab on object. So we need an object to be initialized, and this function is going to return anything, so void. So let's go ahead and do another one. So we also need here the prefab data, which is going to be a dictionary. Yeah, let's just directly access our object to be initialized, and we're going to grab its object data. So here under the data manager, it sets the data by doing from object data.key. So this is the information we want to grab, so we can use here in the code. So it's called object data, and we're going to set this as a dictionary, and we're going to ask for a merge. And we're going to merge this with the new prefab data. So merge allows you to add dictionary entries to other ones. And do we want to override it? So I think we do, because the prefab data is the one that is responsible to pass the first values here. So this should allow us to pass everything we have under object prefab back to the object itself. So now under our basic units, we can build another constant here. So this is our object prefab data, which is going to be a dictionary, is going to be equal to our scripts database, and we want to grab from the units, and from the units themselves, we want to grab the database prefab enums, so the prefab list, and we want to grab from the units worker. So the object prefab data for the basic unit is going to be the one we listed as units worker, which is inside of database units using the prefab list units worker. So that is how this method here works. And we can also now remove this bit of code for the object actions, because this is now part of the object prefab data as object action IDs. Now we need to initialize the actions, but we are going to do instead to initialize the actions placed inside of our object prefab data. So scripts.database is the manager. So do we have actually added the object prefab as here? I don't think we have. Prefab manager reloads the prefab main manager. So we're going to use that. And we're going to prefab the key value, which is going to be from this object. And the key we want is as side of it as script. So hold on a second. We want to initialize the actions contained in ourselves. The action is going to be inside of our object prefab data, inside of ourselves, and the action we want is the object data action IDs. Let's actually simplify this by adding a method here inside of our objects actions main manager to call in to fetch action scripts from that. So let's actually get action script array from a given set of IDs. So action IDs is going to be an array, and this is going to return us with an array of scripts. So this line of code here should return us with an action script array based on IDs. So get action script array from ID, from action IDs. There we go. Now we should be using this function here. Back on where we were trying to do this. So let's initialize it. So here we can say for the action manager dot get from IDs, and the IDs is the object action IDs. There we go. So now we should be able to initialize the actions based on the prefab. We can, I think, also remove this one. This we can set through the prefab. So we want to start the object data. So let's go to the prefab. And here we can say that for the object states, we want to start on idle states. Let's put a comma there. So we start with a state of being in the states idle. So let's see for the basic units. On set startups, we're going to remove that line. And let's see how that's going to work. So the execute state on the physics is going to try to run first. The initializer is not being called. Okay, that's the last bit of parts. So for the startup, we also want to initialize it. So scripts.initializer. It's called prefab. What is called? We don't have it. Constant prefab initializer with the initializer. Let's go back here. Let's exit out of the program. So the prefab initializer, and want to initialize the prefab on this object, and the prefab dictionary is the one we define as the object prefab data, which is fetching from the scripts database. Now it should be good to go. And as you can see, now it starts and with the current state. So I think that is the way we're going to start units. We're going to grab the IDs. So right now our code is, I think, the minimalist as possible. Yeah, this function is just a debug ABB. So as you can see, we only have the startup function, which basically allows us to copy all the prefab information back to the end. We can test this by increasing the speed of our object data for the worker, and let's see if whenever we run, and as you can see, yeah, so it's been set up correctly. So the basic unit, once it's start up, it's going to grab the object action IDs to initialize the object actions, and I think we can do this by doing this as well. Or yeah, I don't think we even need this one. So we can simply say to it initialize the actions. The action is going to be this one. Now it's going to say we don't have the object action IDs. Yeah, so I think we can do this. And it's not self, it's object caller. Now we can also do that. So now the function is even better, I think. We don't need to pass anything like this, just the self one. Yeah, we have improved the function here. And we ask for the initializer. Let's see if it runs, and it does. So there we go. We have improved the action initializer function. So in order to initialize actions, we now do this bit of code here. So we grab the object actions ID from the object prefab data. by grabbing the object data, object action IDs. So we can pass for it to generate the script arrays, and we can call that later. So yeah, I think that does about it. So as you can see, yeah, a lot of stuff to work on behind the scenes, and we still are not carrying the features I had on my other project, but as you can see, it's a step moving forward. So in order to avoid this project being too big, we're going to stop right here, and hopefully you are able to follow up and see the steps I did. So yeah, this is all of the things we're going to be doing on this part. There's a lot of stuff to still do. So we have accomplished quite a bit on this part. We have set up a lot of updates to our systems. We have had an Autoload to be responsible for all the scripts inside the project that we commonly use in order to avoid having to preload them inside of the code here every time. We have added the Prefab data system, which allows us to build databases, which is going to be used to assign back to the object unit. So as you can see, everything you see listed here is going to be added back to our basic unit on the object data. So the code that initializes this is the object prefab initializer, which as you can see is going to merge the information we have stored on the object data inside of from the prefab database back to the object data, and it's going to overwrite any values we have duplicated. So our units, whenever it's startup, we are going to do that. And we also going to initialize all the actions. Now the actions to be initialized, we have updated the code here to grab the object action IDs from the current object prefab data, which is based on the object current action IDs. So if you come here, this is the object actions we're going to be using, but here is just stored the IDs. We need the scripts. So the action initialize actions needs now to calculate the scripts in order to calculate each one of them to be initialized. So every single one of those actions we have built have a initialize functions to set up basic information we're going to be needing in order to use this action. So this in turn is going to be done by the action main manager on the initialize actions. So I'm going to grab the action scripts from the scripts action manager script array from object action IDs, which is going to build an array full of scripts from the action IDs we're going to grab from the prefab data under the object action IDs. Then we're going to finally initialize all of those actions. So we can basically initialize the actions. Then we also have the prefab data to override all those other variables here. So now we should be good to go. So all of the objects are going to receive the data for the actions first whenever we initialize them. Then later we're going to overwrite the object data, merging the dictionary with a set of more variables here. So this in turn allows us to eliminate any usage of the object data, so we don't need to set up vars anymore, and we can control everything here based on the information we have. So as you can see here, I can alter the speed of the object just by editing now the prefab database. We also have changed a lot of stuff here regarding the object unit, so we have stripped away the functions from move, selectable and stuff. So the functions from selectable now are calling directly from the script's actions, from the action selectable, and the new path methods from the units now are being called through the Rts World. So the Rts player now whenever it wants to move units, such as the methods we have here, move units to mouse, is going to now access the script's Rts World and ask it to return a new path. This is because later we're going to make the Rts World process units based on the queue, so we want to pass that responsibility to the Rts World. The Rts World in turns is just to preload the scripts here, but it represents the Rts World as we have here. And this is the script for it, which has the new path which accesses directly some functions here. So the Rts player asks the Rts World to give a new path to the units. And that is how we are moving units. This allows us to remove those methods here from the basic units. So yeah, and we have a lot more stuff to do, but hopefully we'll not make this part a lot more complicated than it already is. The complexity on the project has increased quite a bit, but hopefully you can see the code in the screen and you can do it on your own projects. And if you want to get access to the entire code for the project, the entire thing, becoming a YouTube member will allow you to get access to this project as we are building it. So hopefully you guys were able to follow and you found this video useful, and hopefully we will building our RTS prototype here. So I'll see you guys on the next video. Thank you guys for watching.